Today's date is the 15th of May, 2026. The time now is 17:40 p.m., 5:40 p.m. So, the ontological Bayesian intelligence, reasoning, a software communicate for reasoning. So you got ontological, meaning system knows itself. Bayesian means probability, and intelligence or knows what it's doing. This is solving certificates based on the pattern through by work on ontological Bayesian intelligence and AI systems. Primarily, it's on the rhetorical reasoning rationale, bidirectional or top-down reasoning, bottom-up reasoning, uh, um, to ensure trial consensus. But you're gonna have try a lot of consensus in the framework, but it's biological consensus, top down, bottom up reasoning. But this is basically the ontological Bayesian intelligence solid communicate. I want to share with you guys. So let me just go to the repository and show you what it is. GitHub.com. OB, yeah. So this repository here, you get let me quickly listen to this readme. Readme.md up here. Release. uh, ontological ontological Bayesian intelligence. So system ontology means knowing itself, knowing what it's doing. And you got phenomenological knowing system knowing what it's doing. V1 query tag. But this system knows what it's doing. So I want to focus on application today. So the AI systems I'm doing is literally it is not as it's gonna release the PyPy. So I'm trying to release the Python. So this is a software development kit based on OB. So basically you have here Python, set up the Py, build this, what you do, pip install -e docs. You get install OB01 and Python test test Py. This is code for it. You get a code here. Well, because you get a code here, you have to understand that you get a code base here. Don't know about code here. I'm going to move to the other way. Well, you get test OB. So this I use it, or it's from OB .sdk. Uh, import import OB context is the part context, logic based intelligence context. And this is how you use the library. So you're gonna have uh this supported by default, but everything here is knowing some kind of state, preserved state. So it's like if you're driving some car, if you're an AI system driving a car, you know what it's doing based on the fact, the rhetorical reasoning to justify a claim. So fact, reasoning, the reasoning behind the rational, reason by the fact, and the rational. The reason is bidirectional, and you have two-way reasoning. So you have a rhetorical fact reasoning, bottom-up reasoning, and the rationale for action or situation, statement, expression, intent, or expression, statement, expression, intent, expression, statement, based on the competition model of reasoning. But this is basically a probe that can answer this question. So when this code runs, test Obi the Pi, it's literally a system that can use to it's not based on particle, its own system. It's just its own system, doesn't depend on particle. And you basically gonna bring this so example one. safe driving. For example, one safe driving. Gets the probe internal. Internal probe has data, and if it's a safe state, principle, but here it's external probe. Some of the probe internal, probe external. But you're gonna have to use the context of probe internal, wet roads, and this basically some AI data that will apply some real world data and this is the AI system, but this one knows it best how to navigate that scenario. So I'm gonna run this on Python test ob.py. So this is the external probe. This is the result, OB result that's come out from this example. Just use an example to reason it away, reason systems out of it. So this might not fit like a DAO. System knows reason. The reason is important. It's a competition model for reasoning based on cognition. So the application of this is like you can use it for UI UX for cognition UI. Someone's ability to do something on UI interface, or you can use it for AI systems to make sure they are bias free and via bidirectional top down reasoning and bottom up reasoning AI system. You can use it for so you can use it for proving a court evidence. If you don't understand a lot of things in legislation and legal acts of the system, you use it to provide evidence to court and justify your own clause based on the legal status quo and get money more formally. Spill out some kind of output some text that's more human readable and accepted by certain demographics of people. Tailored text, tailored as if it's text. You can use it for a video game, cybernetics interface video game. You can use it for a lot of things. But this is just one example I'm showing you here. So, without further ado, that's what I'm saying. It's basically, OBI is part of the proof. So let me show you the proof now. So the proof is all here on each repository. If you go here, no, it's not there. Move it down. So this is what this is all the proof of formal algorithm bias device, Bayesian device framework. This is all my work, machine learning models, and this is my because I'm going to make an AI called UAI, and it's going to be part of the openness computing. Formalize the vision step of hierarchy step, develop proof of concept for cancellation in these cases, show quantitative metrics for bias assessment, design experimental protocols for empirical validation. These are just my next steps for Kubernetes, but that brings us to Uchi repository. So Uchi repository or the pattern repository, which means knowledge, it's just all the work of my work, Bayesian, but I wrote some of this with AI, so but they all I read them myself, so I do verify them too. So the iteration, just like this paper written by using a networking framework for identify, modify, and this is what OB AI does. It's a proof of concepts, and it's not proof of concept, it's a proof of proof, it's a proof. And you get like here, data star equals to argmax, probability distribution of data. So for all data star equals given D, where D is the maximum argument for the worst case scenario, consider the system data over data set D. D is such that D of data star is the argument max, where D is a small bias of psi. The optimal parameter or which inherits and amplifies the biases through pattern recognition is a feedback the web reinforces the this is my AI system. So this is the black box models and this is my own converse. So this is my own model here, unbiased system. So this is what OB represents. It's basically unbiased interfaces, unbiased AI systems, unbiased systems that use they use the truth hypothesis. Again, hypotheses are all here. So I'm looking for you to check out this proof, but unbiased AI just by PDF. So we get here the argmax here, the argmax here. I'm referencing my own papers. But this is the pattern rules. So you're gonna input D of the data set of bias psi, example of bias, you know, for training or epochs, for training times, past times, which are called epochs, due to sample in the X epsilon D decomposition, updating model produces pathways. So this is called the system encodes, and this is agreement bias pattern method. And this is it matters so the bias this dimension reduction, this is the three hypotheses, but these are the arguments here. Dynamic module loaded. So this is one module you can load. Argument 3. Inputs, module requirements. Initial code language model, LLM. For each required feature, do identify model from directory tree, load models directly, connect to a core system, validate integration, and 4. Optimize performance based on loaded model, return confuted model load system. And this is what the system does. So this is the system. So the Bayesian, this is our Bayesian one. So this is traditional optimization optimum based on Reuven bias. Basically, this algorithm we wrote here. Algorithm well, bias pattern learning. Just bias pattern of the model, and we're gonna have on Bayesian pattern learnings, but not still a bias here, but it does better. So you're gonna have P data, the removal of bias just by Bayesian inference, and this is what this code is doing. So this is what I'm saying. So this is the implementation of the system. But this is the AI system. So you're gonna have the graph order. So psi of integration of P, give PD P given the probability of data given the distributed data sets, integration of P, the data of psi over D is D psi. So this is what it learns over the integration of D psi. Basically, this is the D for all D psi. So the derivative of psi, which is just D over psi. For each side, there's the integration curve. It's an area curve over there. So this is the area under the curve. Or, unbiased, basically, it's actually unbiased, the area curve. So you're just touching the curve like that. I don't believe this. I do believe what I'm saying. So you have the kind of work I'm doing here. The marginal posterior computational. What's posterior mean? Know what posterior meant? Well, this is my work. So this is addressing to OB Nexus OBR systems. This is the equivalent of having something that will be used here. So how to use this? You're gonna have pip install dash e dots. Oh, I have to put it on the internet. So how do I put it on PyPy? Okay. PyPy. PyPy. No, Python. Python. Let's hold on PyPy. Basically, I have to put it on PyPy. So I have to go to pypy.com and log in. Thank you for watching this video, guys. It's much appreciated. So this is the Ontological Bayesian Intelligence LCK. You see, it's very easy to use, but you see, it knows what it's doing. it knows what you're doing. So you know what you're gonna do with the system. So the system knows what it's doing. It's called this. And you're gonna have completion by that. You can use it for AI completion, like a Quokka AI, Quokka, which is this jailbreak system. Is it knows we're gonna type next. If you want to know ahead of time, it's a system that knows itself. Okay. Thank you for watching this video. Ontological Bayesian intelligence. That was my breakthrough. But I love it, so that's what the truth does.